Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Excited to see her speak, and please,
Thanks.
welcome.
Thank you very much. Steve has given me the opportunity. He said, I'd really like to hear more than 5 minutes about what you were talking about. And then when he told me that this talk was 90 minutes, the ears shook. And then also I was asked to talk a little bit about really two projects, the one that Steve heard something about, which you'll hear about in a moment, and also some other work that's been associated in this space, working with what's being referred to as eScience, and scientists trying to get out of the tangible physical stuff of little notebooks and going more virtual and what that means. So without further ado, just because you don't know me, some of the stuff that I do is from an interdisciplinary background. So mixing computer science with communications theory and art. And in fact, when I was living on the West Coast out here, I spent a lot of my time making music to pay for grad studies and so forth, which explains a longer than normal PhD curve too. But the main thing that I'm really passionate about in terms of information systems design and usability is looking at accessibility in terms of just people getting at information. So I'm going to tell you a little bit about some of the stuff that this work is being built on, which is the semantic web, and then look at two stories in this space where usability design and information systems connect. And the first story is called mSpace, and the second story is called Making Tea. So the sort of motivation for this work is that when things go digital, they can go invisible. What you're looking at here are, I'm based outside of London now, and what you're looking at here is the King's Library at the British Library in London. And interestingly, it's kind of hard to tell from this picture, but you're actually looking at 6 stories of library stacks. And the thing that's compelling to me about this is that you can see exactly how much bookage this area holds. You can see from the number of floors. When you go in, you can see the number of stacks. You can get a sense of what areas are covered and what not, what the periods are, and so on. But as soon as things go digital, when this whole collection potentially goes digital, those constraints and affordances are no longer present in how you get at the information. And there's obvious value from having these kinds of physical boundaries around information, or the perception of boundaries, to be able to scope things, to be able to triage things, to see whether or not that's relevant to you. So the question is, how do you bring some of these affordances from the physical world into the digital world, which is what I've been looking at. And the reason for that is thinking that this does help improve accessibility. So to take it from the King's Library down to the human scale, this is also part of where my motivation has been as a kid, going to the library and being able to explore books, and the pleasure of bringing these things home, carrying them. The number of books you could get at was limited, but there again, the pleasure of being able to pull these things out, explore them, discard them, know how many more you had to go through, had a certain value. So this is in a space that I'm thinking of as self-directed discovery and knowledge building. And part of that knowledge building is just knowing what's there and how it's related. And I'm also a very big fan of the Dr. Seuss approach to life, in which there are multiple ways of exploring things. Dr. Seuss helps kids read, and it has this notion of I can read it all by myself, because it uses images, rhyme, various other structures that are implicitly and explicitly available to help a kid get the message of the text. So how can we do that again in digital systems to support this I can do it all by myself effect? One of the approaches that's, of course, very popular and very successful is Google. But with Google, there's a certain assumption that you do need to have certain knowledge, because those constraints aren't there, I'd argue, like the stack shelves and other information, that you have to be able to use keywords in order to find what you want. You don't have the ability to point to something and say, like that. So if we take the Google example, we look at that as a counterexample to this guy here, who points for anybody who recognizes him. Yeah? It's Vannevar Bush, yes. So Vannevar Bush, being the guy commissioned by the government during World War II to look at science, wrote this piece that some of you may be familiar with called As We May Think. And the interesting thing about this is that his motivation was he was really concerned about, and most people know this because he talked about the memex, this idea on which hypertext has been founded. But really he was motivated because he was concerned, what are we going to do with all these scientists once the war is over? There's so much stuff that they'll have to read. How are we going to make sure that their energy stayed channeled for good? So it's a strange motivation that hypertext is built on. But one of the key factors about the Bush approach with the memex was this notion of association. And the folks in the room who are doing stuff with exploratory search know all about the value of association, but Bush is one of the first people to put it out there in the public domain, that how we explore information is not the way computers build indexes and having to search along a system-devised path, but that we can search by association. That's his idea. And in fact, I'd say that Bush wasn't proposing so much an engineering solution as a UI vision of what interaction with systems should be like, and that we would get new forms of exploration. And right now, keyword search is only one model that doesn't support association, especially when you see its list of results. They are not associated with each other other than that they match those keywords. They're not aware of any associations among their little bits. So how can we move to this? Well, mSpace is an idea that I'm going to tell you about for associating information, doing some of that automatically to help support doing some of it by one's own type of exploration. But first, I'd like to take a jag to some of the technology that we're using to enable this, and that's the semantic web. Now, what is the semantic web? Jim Handler is the person pictured here. He's the second author on the famous Tim Berners-Lee Scientific America article about the semantic web. And one of the problems he was saying is that if you want to know an answer to a question like how many cows are there in Texas, it's very difficult to get just a sense of an answer. You have to kind of pull this information together. And in fact, there was at one time one site which did purport to give you an answer, so that you didn't have to go through a bunch of pages and do the analysis yourself. The idea of the semantic web was that you would be able to have inference over associated information, so that the query didn't exist in the page. It could be constructed for you, and you could get a variety of answers. According to these sources, the result would be this, but if you looked at these sources, they'd be this, unless you do have one page that says there are no cows in Texas, they're all aliens. And in which case, trying to put together analysis is not that particularly important. But that is the mission of the semantic web, is to be able to infer from information that exists new information that could possibly better answer your question. So in a sense, what some of the proponents of the semantic web have been suggesting is that you get Uber search out of the semantic web, because you can construct new knowledge, because machines will be able to parse information via these things called ontologies, and the result will be the answer that you want. But that's a kind of, again, Google-esque, if you will, or Uber-Google-esque inspired vision about what people want when they explore things. If we go back to the image of kids in the library are having fun because they're looking at a bunch of stuff. And there's a value of being able to, again, build associations. So sometimes simply getting to the answer assumes that the only kind of question you want to ask is one that has the answer, as opposed to doing something more exploratory. So, but beyond this, what you want or what you require in order to put together any kind of rich association is a lot of metadata. Data about the data that enables you to put it together in new containers so that you can do that association. And there are a variety of models for doing this in the semantic web, and that's kind of what I'm interested in the semantic web, is that it wants to make associations among heterogeneous models. The interesting thing, and this is just sort of a philosophical or sociological aside, is that there are certain caveats around the semantic web, and that we've seen this before. The notion of ontologies, just to go back one, is that the ontologies are descriptive of possible meanings that something could have, so that if Amazon defines a book one way and another store defines a book another way, that somehow a mediating party will be able to map these two things together and understand if they're talking about the same entity or not. And this need for these mediating ontologies is a driving force behind the semantic web. We want to be able to have these descriptive associations so that we can make these connections among things in new and exciting ways. But where we've seen this before, this drive for being able to effectively describe and categorize things, is actually a little over 100 years ago with the Victorian era issue of taxonomies and everybody getting excited about kingdom, phylum, class, order, race, genus, and species. And there's a construction in postmodern theory that says nothing's innocent. There's some sort of motivation behind everything. And part of the issue with the Victorian tree of life as proposed here was that the desire was to make sure that mention was always at the top, that men or humans were always at the top of the chain. So there was a motivation there to make sure that all the categories related from this huge part of the tree, so that people were on top, and men in particular were on top. So that was a motivating factor for the desire for having taxonomies, to be able to understand things. And it didn't really matter whether you were an evolutionist or a scientist, because the evolutionists believed that man was created to run the world, and the evolutionists, interestingly, were trying to reach the same conclusion, but by a different framework. So again, this is just kind of a question as an aside, is that what might we be saying similarly now about the desire to have ontologies and mapping things in similar ways? What's at the top of the tree, or is there one at this point? But in any case, the quest for data is also reminiscent of this other story of Adam, when he was given the mandate to go out and name things. And now we can kind of understand why that naming was so important, not only for keyword searches, to be able to find things on Google, but also potentially when Google goes away, to think about new ways of possibly coordinating things as well within the web space, so that we can get to new ways of exploring search with more cows. So I'll come back to MSpace and just leave that as a kind of question to think about. What is the implication of this rush for ontological technologies? MSpace, instead of Google's lists, tries to leverage associations that have been described among data bits, so that you can have something like what I'm showing here, is multiple ways of being able to pull information together. This CS Active Space over here is a way of letting people in the UK look at who's doing what kinds of research in the UK, so that they can decide, I'd like to look at an area. So it's allowing for multiple ways of looking at information. This is pre-Google Maps, is that you can, by choosing a zone on a map, you can focus in on where you'd like to see research being done, and by the next column see the research area, which research areas are available, and then who's doing the work. And the idea in the space is that as you select any element in one of these columns that's generated from collecting information from a variety of heterogeneous sources, you can see in one page information about that source. Similarly, in this next instantiation, this first one we rolled by hand, this next one is based on a framework that we've released. The idea is, again, helping people to explore by being able to manipulate, and I'll show you this a little bit more, manipulate information categories and associations. what we know about music, for instance, is that in this case somebody has selected modern, has selected Elgar, so that information shows up in context about Elgar, being associated with that information. And they can see the pieces associated with Elgar in the space that's been collected. And down here in the right-hand corner, if they found something they like, they can very quickly double-click on an element and have it added to a triage space for later. Now, the problem that we picked on here in terms of classical music is that, well, let me go back one sec. With classical music, what I'd like to touch on is this looks kind of interesting, that you can pursue things by different categories and explore things through their facets, but music is a very non-textual medium. And as you know, if you're trying to find music that you don't know anything about, in particular classical music, it doesn't matter how well organized the information is still going to be meaningless to you. And we've tried to address that by associating some kinds of descriptions with the informations, but again, textual descriptions can fail because there's nothing like hearing it. So we've integrated a way where you can actually preview music as well to get a sense of doing what Kathy Marshall's called information triage. I'll tell you about that in a moment. Let me first tell you a little bit about what these models are that you're looking at. MSpace itself is predicated on a high-dimensional model, that there are a bunch of dimensions in a domain space. And we know that human beings are not very good at managing visualizing high-dimensional spaces. So what's the possible solution? We looked at a variety of visualizations, but what we ended up doing is saying, okay, if we take a high-dimensional space and we imagine looking at it through a plane as a projection, we can flatten that projection and get temporary hierarchies through a slice of the domain space. So what we've said effectively is allow people to take whatever elements from a slice through that dimension they wish, make selections, we call this a slice, make selections through this new hierarchy so that one is dependent on the other, so the right is dependent on what happens in the left, so that when you make a selection in the left, it gives you information about that attribute, but also constrains what's going to appear in the next dimension. This might not be the way that a person wants to explore the space, so we've also said, okay, let the person at any time swap out a category or a dimension and replace it with a new dimension in the domain. And if you wish, also add new dimensions. So what I'll show you in a second is a video of this operating, so that again, information is persistently available in the same window with you, but we're using a very simple visualization technique, a spatial layout, in order to support this understanding of temporary hierarchies to explore an information space in a way that's relevant to the person doing the exploration, or as relevant as possible. I'm not going to go into this, but some work that I've done with a grad student, Michael McGuffin at U of T, and also with Alan Dix in Lancaster, has looked at what are these models of, and it's inspired by George Robertson's work on polyarchies. And in fact, the MSpace, if you get into the formalism of it, is a special case of polyarchy. And the advantages of being able to describe interaction models according to such formalisms is it means you can give them to anybody to implement any way they want. And as I've shown just one visualization, there are certainly many others that are possible that we'd like to explore based on this model of interaction. So what I'll show you is a couple of demos about the various affordances going on in this interface to help people answer the question, I may not know much about classical music, but I know what I like when I hear it, in order to explore that space a little more richly. Yes?
Question. So,
sure.
When I've done exploration in this space, one of the problems I ran into is that the more space you give to the facets, the less you have for the content.
Right.
And so I'm looking at this right here, the actual content is just that, it's a tiny little box that says when you consider Schubert's.
Yes.
So do you have any strategies for...
Yeah, the latest version of the framework, this is 0.4, the one we're coming out with 0.5, hopefully by the end of this week if all goes well, has controllers here to enable them to be expandable, and I'll show you a demo of that. That's been a sort of midterm solution for us. I'll show you that on a mobile device in a sec, Dan. Okay, so that's a previous demo. So here, and I hope you can hear some of this, is that someone is just highlighting over the music here. They pull up a variety of cues that are associated with the space of interest, so that by listening to that, they can rapidly decide. It only takes 0.25 of a millisecond for a human being to make decisions about audio. So by making these audio cues available, associated in context, people can decide whether or not they want to drill down into the space. We've tried this model looking at how many preview cues we associate. Initially, we were associating 1 cue per track. And then we were challenged, well, what does it make a difference if you offer more cues, or shouldn't you offer more ways to look at a space? 1 cue might not be representative enough to make a decision. And what we discovered is that it really doesn't make a difference to performance whether you offer 1 or multiple cues. But what does happen is that people's patterns of exploring the space change. So that if more cues are available, they tend to explore a space more deeply than if 1 cue is available, and they tend to move across the hierarchies more rapidly. But that's the only difference. So depending on what is available to you, the bottom line is you still get a tremendous benefit from associating multimedia cues with a space. We did another version of this, just wrapping it over the IMDb database and leveraging things like genre and so on, so that if somebody said, I don't know what a film noir is, but they've heard about it, they, instead of getting audio cues, they get a couple of trailers of film noir films, so they can make a decision about whether or not this domain is of interest to them. And we found, again, comparing with having the cues available early, most technologies these days only have cues available at the instance level, not at what I've been calling the area level. And the difference in satisfaction and performance in being able to make a decision about whether or not somebody wants to keep something is significant in terms of the ability to move through this kind of space rapidly, or having to digest a lot of textual information that is experiences not being particularly helpful when there's no examples associated with it anyway. So that's one simple technique. And it is really cheap to add this. The other one is this notion of sorting and slicing, or what Gary Marcianini calls slicing and dicing. This, again, is an earlier version of the interface. We're working on just a kind of drag and drop. This is all done in JavaScript so that it will run on any web browser effectively. Well, it took us a while actually to get IE compatibility with open standards on the JavaScript. But the idea here is that somebody's looking for information and they decide that they want to look at this point for artists associated with cello music that they might, this was an actual person doing this, it might have been associated with something that they heard the other night, and it was by a guy that sounded like his name was a toy, and we actually happened to have it, so that was great. And so they were starting to look for some tunes that might be of interest to them from this. Was this what I heard the other night? And what was freaky was they nailed it in one. That was just a complete fluke, but they were able to do this kind of two-layer triage, sound and text, where they were looking for stuff that they were interested in. And what will happen is this person will save this cue to come back to later, and then they start talking about, well, I don't really care about eras or what period somebody was writing in, or really that much about composers primarily, but I do know that I had to take piano lessons as a kid, so I'd like to see how the world looks if it's arranged by piano. So they actually, I think they do some cello stuff, but then they change it over an arrangement to piano. I think they've done that. So that, again, they get the information. The sizing wasn't normalized here. And another thing here is that if we don't currently have information specifically about what's available, we'll export to a constructed Google search that takes the terms that they've already used. And the reason that's okay at that point is that they're deciding, yes, I want more information about this specific thing, so we can construct a context for them. But one of the powerful things that we found about this is this ability to redo the slice. Nobody's really aware of the fact that they're remanipulating hierarchies, but the value is that they get this experience of being able to make assessments about the space, and how they spend time in it is then different. One other thing is that the other thing we've been looking at is how can we help them do this. So for instance, if they're doing stuff like pulling out a bunch of piano pieces from a bunch of different artists and they haven't picked piano as the first thing that they're searching on, we can tell them effectively that if you made this piano first, you'd have the effect that you're doing right now. Do you want that? We've been calling that power assist. Danny?
Do you find that people understand the ordering?
It's really interesting that they haven't had any difficulty with this, and we've been trying to find out why that is. And I think part of it might actually be applications like iTunes and other multi-column layouts that enable people to just slide things over. I'm not sure that we're actually there yet, and there are other models that we could be looking at, for instance, where this isn't constrained, so people just have a list of dimensions and they can start putting them down in any order at all. One of the problems we have had with that in just doing lo-fi prototyping is what one person thinks should happen next is really different from what another person thinks should happen next. So we've been finding that this is a fairly light constraint to enable us to do predictable manipulations, but I'd certainly be open to exploring other models.
Can you relax a parent without blowing away all the children?
Yes. Okay. So that's a quick overview of what we have found to be useful. And just to summarize, I'd say that one of the main things is actually having associated information available peripherally that people may or may not wish to focus on, and then enabling them to focus on this by letting that window expand if they want. But this triage area is perhaps the most important area for people going through the space, because it means they don't have to keep track of what they found. This can do it for them. Preview cues, of course, are really useful, and I'd like to see that explored in different kinds of media as well. One of the other things that we've been doing, particularly in the mobile space of this application, and again, this is sort of MSpace on a PDA mobile phone thing, that's the prototype for it, is the ability to support lightweight annotations. So if you've made associations with something, you've explored something, you've got it down here in your favorites where you want to come back to, you might want to be able to make some comment about whether or not it was a good thing that you found or some other kind of annotation. But the first thing that we've been looking at is recommendations, lightweight recommendations to make that easy so that you can see if there are other people that you know who, or trust, we're looking at trust relationships, not just known buddy relationships, who have rated something. You can look at what they think of the place too and see more comments on that. I'll just show you that quickly so you can also see then the animation of the window. This is just how we've been dealing with being able to look at spaces. This is a context-based browser that we've been working on in London. So here's the comments expanded so you can see not just ratings but things that other people might have said or written about something, or look at other content. Again, you're deciding based on, the map is moving based on your location or what you want to look at. It starts where you happen to be in London, and then you can look at things associated around you. So for instance, if you said, where's a movie theater showing, it's a compound query effectively, where's a movie theater showing the film that I'm interested in that might be close by me, and is there a Japanese restaurant close by that as well? So you can propagate multiple things onto the map to be able to explore it in context and association. And again, if you enjoyed that, you can provide annotations on that thing to share with other people in that space. So again, this is a lightweight way of publishing now to the web, leveraging the notion that blogs is making it very easy to publish. This is a fast and lightweight way to publish. We've also got a concept in here that we call GPS Ghost, which means that if your device is GPS enabled, which this one happens to be, it can remember where you've been if you've spent time someplace, and rather than forcing you to annotate that now, you can come back to a listing of the places that you've spent time at, and if you wish at that point, either on your computer or on the device, make comments about whether or not that was of interest. We found this, actually, I was talking with Abigail Sullen at Cambridge that promoted this idea of her saying, you know, sometimes when I travel to a city that I don't visit that frequently, but I do visit, and I want to know, did I go here before or not? Is this the place I went to? That this will take care of that problem. Okay. I won't go into details on the architecture, but we have been doing this notion of a distributed architecture so that it's easy for people to publish, whether it's from their blogs or whatever, information that could be associated with information about an entity in an MSpace. So for instance, there is no one the Beethoven description, but we can pull together annotations of information on that so that people can have a variety of sources to look at. As I said, I'm not going to go into detail about the architecture, but I'm happy to talk about it with anybody. We've done some other things where we've collaborated with different groups. In this past example, this was photos during the W3C conference a year or so ago now, where annotations from one application published to the Semantic Web could be picked up in another application, so that as people were going to different sessions at the conference, and if they didn't know who an author was and there's somebody taking a picture, they could see that. And yeah, okay, so it's available on SourceForge, or if you just go to mspace.fm, you can download the framework and apply it to your own set of information sources if you wish. And as I say, the new version of that should be available at the end of the week. The main thing, I guess, to take away from this part of the talk is that we're trying to provide new ways to enable people to manipulate and control information, but also to triage that information rapidly, to make assessments not just about instances, which I would argue is sort of what keyword search forces, is that you're looking at a set of discrete instances. What we're trying to explore is what happens if you can look at areas, if you can look at global connections among things based on what their inherent associations are and what associations you would make among them, and how you could have possible multiple MSpaces on domains interlocking with each other to support the I can explore it all by myself approach. I'm going to jump into a different story now called Making Tea. And MSpace is a way to explore the information once you have it. In the eScience community in particular, there's a challenge about how do you get the information to begin with, because often it's locked up either in paper or in digital forms that are not readily shareable. If you go into a chemistry lab in chem informatics, you might find a suite of machines that are all hooked up to computers, but those computers aren't networked. They all have their own file formats. There's no sense of information sharing. Every machine is an island. So we're looking at how to improve access. Making Tea is really a design elicitation technique that we developed for a particular kind of task, this notion of a highly expert and loosely structured task that can last for a long time. Why would we bother with developing a new method when there are so many design elicitation methods out there? Well, what we ran into as a wall is that the existing design methods, and I won't go through them for you, tend to assume that you can, as an observer, know the domain. If you're working with somebody in an office environment, you have certain things in common with them. You know about making phone calls, about using email, and so on. What happens when you get into a domain that is highly expert that you're not familiar with? There are various methods like apprenticing and prototyping, but again, there's an assumption that in an apprenticeship you'll be able to grok how to monitor a panel on a nuclear display device within a certain amount of time, or if you're putting wood through a processing machine, you'll be able to get that in the normal time it takes to train somebody, which is not years. A scientist is a highly trained and idiosyncratic person, and sometimes rather nasty. And so trying to understand what that person is doing when you can't even observe a complete task underneath a couple of months can be a bit challenging. The other part, just as background to this, is that within this community in the UK and the cyber infrastructure space here in the States, there's a desire to look at what happens if you can share information, scientific information that's previously been excluded from sharing, and make that available to people. The question is, how do you make it available to people? We're using, again, the Semantic Web in order to pull together a lot of information that people can comment on differently. This, again, by the use of ontologies, enables this notion of a network effect, is that you can have one little seed out there that has a variety of information bits associated with that. Again, we need metadata. People hate annotating, so we need some really far-out UIs that can leverage as much as possible what's going on in their space in order to support this practice. But again, before we could even get to the UI, we had to understand the practice. So I'm going to take you through two stories. One's kind of a done story, the other's in process, with chemists in a wet lab and bioinformaticians in an in silico space. In synthetic chemistry, you'll see two things here: a bench that has a bunch of stuff set up for an experiment, and a lab book. And of course, lab books are great. They've been in use since the 1600s, more or less. Before that, if you count non-specifically experimental notebooks like Da Vinci's, but for formalized experiments, the paper's great. It just has certain inconveniences, like a difficulty of being able to share it. Just as a note, we were really hesitant to get into this project because there's tons of digital lab book things out there, and the reject list of many of them with the chemists that we worked with is long, and we were fearful, what are we going to be able to contribute to this space? But one of the notions that we had was most of these appliances have been based on the notion of maintaining the metaphor of the book. What if we stop looking at the book as the design end and look at the book as an affective experience? What are its properties, and can we redesign that so that it can be better deployed in a digital environment? So we did a field study, and we looked at how all these lab books are functioning in the lab, and it looked at its social and ergonomic and physical and legal and historical properties, and I won't go through them all with you, suffice it to say we did them. But the problem is we still ran into a wall. And again, this is just a sense of the environment, is that what we really wanted to know about is how these experiments were actually captured. What's the decision-making process that one scientist will write things down at one place, and what will they write down? And because we didn't know chemistry, it was difficult for us to define and divine what was appropriate to be putting down onto all these sheets that they had to write into many times. And sometimes they would write on glass. Here you see one side of the lab, the bench side of the lab where they set up. This other thing here is the fume cupboard, which is more or less like a kitchen stove where you put things together to cook them up and heat them up. And so if they're working over here and their lab book is over here and they want to make a note of something, they'll grab a wax pen and write it on the fume hood, which they'll then have to transfer later into their lab book. So there's some interesting ergonomics at place in a lab. So our problem was, as I've said, this gap between what we could simply observe, and this is where I'm saying the methods sort of broke down for us, and what was actually going on at the fine-grained level of when a decision would happen to write something down. So I'll skip through the related work. And in our lab, there are a bunch of British folks and me, a Canadian, and when anybody's frustrated, the thing to restore your soul is to make tea. And we actually did suggest, let's take a tea break because we're having a block here. And our team chemist, Graham Smith, said, well, actually, doing an experiment is a lot like making tea. So we said, let's do that. Let's make tea as an experiment. So this first line here is just using regular kitchen utensils and Graham's lab book and asking him to make tea as an experiment and write it down. And then we iterated on this and started jacking up the equipment so that we were then replacing tea-making equipment with what you'd use in the lab to begin to understand where are the differences, what happens when you start handling more equipment. Does that have an impact on what you take notes of? And what this started to become was a way of deciding what actually gets written down when and why. And the reason tea was so helpful to us is, for one thing, making tea takes 10 minutes. You're done. So there's a lot of space to talk around. Making tea is something both the chemist knows how to do and we knew how to do. I shouldn't make any comments about if there were any Americans in the room. That last assumption mightn't have held true. But we at least had a shared understanding, except for one point, and this was really critical as well to our understanding of the design process for this and communicating design issues. We could elicit difference. We could say, okay, the fundamental historical question about making tea is, when do you add the milk? Do you add it before you add the tea or after you add the tea? And whereas it might make a difference in terms of making tea, and again, this was a great incident for us, is that we discovered that chemists have actually published papers on when or not to add the tea or the milk first and why. So it was by fluke that we hit upon the making tea method as a way to talk to other people in the project about design, but it turned out that we stumbled upon a rich argumentative culture. And in fact, if you look at the website for this project, which is smarttea.org, with 2 T's, you will see a list of these chemistry papers, including George Orwell got in there at one point, and one paper from a physicist who says it has nothing to do with the tea or the milk. It has to do with the vessel and what kind of vessel you use for that. But what this gave us, again, was a notion of being able to elicit difference in practice. So the answer is, you can argue about the tea and milk thing from various chemical properties, but in terms of an actual experiment, it doesn't make any difference which you add first. This was important to us, again, from a design insight point, so that if a chemist wrote down, they all have to write down, these are the things I'm planning to do, and this is how much I'm going to measure out, because it's all about moles and molecular weights and so on. So they do have a plan of what they're going to do, and we could leverage that. But if they did it in a different order than what was written down, it didn't matter. That was important because it said, okay, you don't have to force that as a constraint. If we had just watched them do a real experiment, the likelihood that if they said, we do this, then we do that, that we would have gotten that that's not actually important what order you do it in, it's just that you do it, might not have happened. So tea was really useful for being able to elicit difference in practice for us. Also to have a common language. This is sort of the participatory design thing that Boker talks about in terms of design language. But also, we didn't have to become chemists, and they didn't have to become designers. We were able to have this middle ground that was useful for both of us, that kept also a lightness to it, because we weren't asking them to use dangerous equipment. When we had them in for design reviews, we could use this experiment as a way to walk through our design, find holes in it, and stop and talk, because the only thing that would happen that was bad was that the tea would oversteep, which is something else we learned about chemistry, is that you can leave things on once they go to a complete reaction. They can just sit there forever and they're done, so nothing is spoiled. Other differences, again, design, elicitation, difference. So we were able from this to get actually that we were getting a lot about our design assumptions incorrect in the way that we wanted to over-capture things. One other thing that we found out about chemists is that they're really macho, is that this is an entire experiment, just these lines right here. A chemist might take 20 times to filter something like getting the tea filtered out of a vessel. They'll only write down what the final result was. They're not going to tell you how many times they did it. So again, we would have been inclined to over-capture everything they did as if it was important. But for them, no, that's not important. Their culture is they don't want to tell people that they screwed up doing it 20 times. They just want to tell them that they were able to achieve a result. And so again, we were able to prototype rapidly with this as a design template, and then we were actually able to validate the model that we got for tea against more sophisticated experiments to make sure that it still worked out, and we were able to begin to do translation on the design. I'm not going to spend a lot of time on the design that we came up with, because that's almost incidental, except to say that it worked. We deployed it on tablets, not because that was necessarily the best way to deploy it. I wanted to look at also deploying things in situ as opposed to always having to carry around your own device, but we just did not have the funding to do that at that time. We put it into science. They're now using it in 2 labs in the UK, so it does end up working. But how we tested this was really to see if the scientists just could get on with their work and ignored it, because they certainly didn't ignore the designs that they rejected. And so we were looking at Dillon's process outcome affect, and really to see, could they do what they wanted to do? Did it give them the results that they expected? And did they feel empowered using it? And the best way to see that was would they ignore it? And when we debriefed with them afterwards, what we found was a real surprise was not that they wanted to talk about the device. So we had, in fact, to prod them a little bit to say, well, what did you think about this? It was, yeah, that was fine. That was good. You could have had a bigger eraser for when I'm doing my sketches. But other than that, what I really liked about it was the fact that my data was captured. So again, sometimes evaluations, you expect people to say, yes, I liked it, no, I didn't. In this case, the fact that they didn't comment on the design was a positive for us. and that we could get at these other things that they found valuable, this belief that their data was being saved. So instead of being in the lab book, they didn't talk to us about this, that they were worried that their data was at risk from lab books. This never came up in conversation. It only came up when they were actually getting it. And to tell you the truth, we were certainly storing their data at that point, but we didn't have any real structure for getting it back out again. So they were only half right at this point, but we were really, really happy that the bottom line is that the perceived cost to them of setting up an experiment to use with the system was well balanced by the multiple benefits that they had from being able to access their information wherever they were. So making tea with our process let us enhance other ethnographic methods to do design where we were stuck. It also gave us a way of, as I say, validating our model. This might work for a cup of tea, but is it going to work for a more sophisticated experiment? And it also gave us a mechanism, we'll skip through this, it also gave us a mechanism for being able to design the middle layer architecture, because again, we had a model that was well defined that we could give to other engineers on the project to say, this is what we want to model, and insights into the layers of the model that we want to be able to support, which was what's planned, what's actually done, and the provenance of the things that are done. So that was also an insight that we wanted to be able to capture these types of displays. So that all these things are good about rapid connection with experts. And so we wanted to test this, take it on the road and say, okay, that worked fine for chemists. Maybe we were just lucky. Let's go work with the gnarlier problem of bioinformaticians who are already working everything on their computer. So what possible problems could there be there? Well, they came up, and again, we asked the scientists themselves, we'd learned this time, to ask the scientists to come up with the analogy. And the model has developed such that we say, ask the people you're designing with how they explain it to a 9-year-old or how they explain it to a grad student. And that's a Kurt Vonnegut thing. He said in his writing that if you can explain something to a 9-year-old and a graduate student, you can explain it to anybody. So if we could get folks to give us the analogy that they would come up with to explain how they do their work, we asked geneticists how they would do their work. And they said it's like putting together a jigsaw puzzle with the following constraint. You don't know what the picture is that you're building, and you're not exactly sure if all the pieces you currently have actually fit that picture or are parts of several pictures. So as soon as we had that, we could begin to understand, oh my God, there is a problem here, because in terms of their current practice, the way they work is that they don't have this part, the table, on which to do their work. They work everything in the computer. They hack together, as I'll show you, Word files and Excel spreadsheets by cutting and pasting stuff off databases that they access from the web. So that there's no place to put stuff when it's in process. So that when something gets chucked, for instance, they might say today, this piece doesn't belong to anything interesting, and then tomorrow, or 6 months usually later, find out that that might have been interesting. So our mission was to help stop stuff from dropping on the floor. And as I say, we are in the middle of this process. This is some of the web pages that they'll go to find gene sequences and be able to pull them together. And as I say, they rely on Word and Excel to make tons and tons of files. This is from one bioinformatician who is extremely hyper-organized. By that I mean she puts things labeled correctly into folders that have matching labels. Most of them don't. This is only a screenshot of 109 files for one gene sequence that she's looking at. And as I say, she is atypical in the way that she keeps things organized. And when they don't have something that'll help them, like Word or Excel, they have to cobble things together by themselves. So the idea here is that we want to begin to capture some of the things, and talking with Ed earlier about some of the searching on personal information, we want to likewise be able to capture the information that they're creating in context as they're doing it, so that it can go into what they don't have now, which is a kind of virtual lab book. They have no lab book. Everything, as I say, is just ad hoc Word files. And so by taking information like, I've just run a gene sequence from this web page on this date, and being able to make a record of that that's annotatable. And what we're starting starting to learn about annotation is that there's a set of defaults that these scientists would like to have, so they don't have to come up with their own labels all the time. They want to reuse a palette of labels so that they can say where things are at. So I'm probably telling you things that you guys have already discovered. So we're putting this together as one part of the picture. Another part of the picture is how do we create a virtual bench so that instead of right now they just go to their Word file or whatever and crack open their lab book, or not lab book, but their laptop, and think about this process, that we give them a place to work in, that we create a virtual bench. What would that be like? Well, in talking with the software engineers, we came up with yet another analogy to say, where in software does this idea of a virtual bench already exist? Because actually in eScience it doesn't exist yet. Is the notion of, in music systems, do any of you work with music? You have the notion of a multi-track recorder. In the analog world, you have a big mixing desk and you plug in all your instruments to it, all your source files, but you also plug in things like effects. So the reverb to make it sound like you're in a huge room or not gets plugged into this console, and you can affect the result. And the result is, if you wish, like a completed report, is a completed piece of music where you can say, this is the production. And you can go back and tear it down by seeing when you did what particular edit. Good virtual software will let you replay versions of what you did, but it keeps track in a sequence list. Sequences, there's a happy coincidence there, of all the bits you've been playing with. So what we've been looking at is how can we encourage people to think about, instead of writing standalone hacky tools, to think about what's a framework. So we're looking at the MIT bench or MIT sequence container, but the goal is not to have just our bench, but for anybody. I mean, there's lots of sequence software out there. There could be lots of these kinds of benches. As long as they enable people to plug in the tools they want to use, as long as people can write tools that will help them process the information and output a report. So some of the early tools that we've been looking at that have come, now that we have this model, we can say to the scientists, we understand the jigsaw problem, and they've been relating to this and sharing it with others. And we can say, so what we want to do is help find tools that will help you, first of all, do the analysis and capture. So what do you want to capture when you're looking at the tool to see whether it's, you know, a piece of a flower or a piece of outer space? What tools are they? What are the outputs from them? What would they look like in a report? To do that, hang on to that, and use that hopefully as a specification that we can begin to develop for scientists and people who want to write tools in this space to say, okay, to have your tool coordinated, write it this way so that it can talk with these other tools and the information can be shared among tools rather than just sit in your own little box in your own little machine. And we're getting some traction on this, and web services is a big help here, but thinking of them coming back to the desktop instead of run-off isolated web pages. So this, as I say, that I'm probably started to speed up talking because this is fairly current work and we're rather excited about it, and it's, yeah, very in process.
Question: in a sequencer, I mean, you pass along like a sample, so it's a sample sound,
yeah,
and it's very well defined, like this time slice. What is it you would pass around? I mean, extending the sequencer analogy, what is it really you pass on from one station to the next?
It's actually the sequence data. It's actually, I can show you something of what that looks like, but I don't have a big blow-up of it. Yeah, just a bunch of letters. If this is sequence data. And in this case, the geneticist has gone through manually color-coding the matching patterns. This is a simple task. So we've written a little tool as part of our first tool on the bench that simply detects what the genes are in this sequence and makes them clickable, so that the scientist, when they want to discard that piece, they can click it off. And so it's logged in the report that says, you looked at this sequence on this day and you turned off this section, and they also want to know why did they do that. Well, it turns out usually it's just bad garbage in the original data, so that's our default metadata tag, and if it's not, they can change it. So there's an okay, is this the appropriate default that you want? If not, choose one of the others or write your own. So that's the information, and I'm learning this right now too. How much of that do you want to go to the next tool then? Because what happens after they've done this simple thing is they take the cleaned up file and they run it through something called an alignment. this is what some of them do, to then do this comparison process. But there's no record that they have that they did that alignment. So simple, simple, simple things start to create a gestalt experience for them. And the next stage in that is then with this notion of simply keeping track of things that you can click on and off, is that from this outline of a report, they can then say, go into share mode, because we're writing all of this again on top of a triple store, Semantic Web, Semantic Store, is that we can say, I'm in share mode now. I want to share this, this, and this with my supervisor, and I want to share just the screenshots I've captured. That's one of the other wrappers that we're doing, is that they can take a screenshot and it can get dumped to their report quickly and link with whatever the associated file is, that they can share that information that's just the representation of what they're doing, or they can also enable the person looking at that report to go and get the original source data. So the surprising thing about this is that there's not a lot of heavy lifting going on here. It's just doing some things automatically that it is very possible for us to do automatically, and the net benefit is that suddenly there is little bits of efficiency that we see coming into the process, because now there's not the mental load to have to manage these things, that they can forget about that and concentrate on the work. The big question mark that we have is, what happens when they can start sharing stuff? This is the whole eScience question. Scientists haven't shared this stuff before. What happens when it becomes a simple thing to do rather than a big effort of, I have to pull my Word files together, I've got to put my notes together, I've got to decide what I want to show you, oh, that's too much. If this becomes point and clickable, what happens to science? So I'll just finish up for you now. I appreciate you taking the time. So yes, building analogies, good for design in this kind of space. Helps us get closer to publication at source, and the I can do it all for myself, shareable idea of supporting scientists in this case to focus on what they want to do rather than the mechanisms by which they have to constantly manage how it can get done. This is my one caveat about access, is that once upon a time, Eve asked for access to information, and the results were not historically or mythologically very good. I'm not sure what the analogy here would be to that, but I'm sure there's a warning in there somewhere, so I wanted to put that out there. The other thing is we're doing a workshop about design issues in usability design for eScience, and we want to look at that from, what are tool issues to what happens when you start to change science. The methods that you're able to use, the tools that you're able to use, what you do affects what you observe. So if any of you are interested in this, if you go to the mit.org.uk website and go to UWS for Usability Workshop, please think about coming over. We do have some travel funds if you poor Microsofters need some help. So, but it'd be terrific, again, if you're not doing stuff specifically in eScience, but you're thinking deep thoughts about technological change and exploratory search, that would be absolutely fantastic. So, yeah, the message, the takeaway here is access to information might mean different models in terms of exploring information when it's not an answer per se you're looking at, but building up a story that you'd like to be able to learn about and to tell. So thank you for granting me access to this group, and in a few moments we have remaining, I'll be happy to take any questions. I won't guarantee to answer them. In fact, my favorite expression is I can explain anything as long as I'm not constrained by accuracy. So thank you.
So one of the things I'm curious about for the scientists is that they often cobble together these special purpose tools.
Yes.
Because they don't necessarily find the ones that they need, or they're doing something.
Or they don't trust somebody else's. Yeah.
So it seems like you want to be building this workbench, this toolkit that they can use to do and make it pluggable.
Yes.
But that is an architectural question here besides usability.
Yeah. Yeah.
Are there people attacking that?
Yeah, and again, to use another analogy, to stay with the music analogy, one of the tool sets that you can get in music is virtual synthesizers. And with virtual synthesizers, they have a lot of prefabs in them of sounds, whether it's, making it sound like a piano or making it sound like a violin. But there's tons of parameters there that enable you to switch the thing so it sounds like something else. And what we're learning is that the reason that the scientists are cobbling together these Perl scripts largely, and because one thing doesn't do the other thing, is because all of the other tools that exist only do the one thing. So if we can start to understand what some of these common things are, because they are fairly common, and make them switchable, so that you can turn off or on or adjust these parameters, I think we have a chance of getting to more general purpose tools once we learn what those parameters are. Because, as I say, simple little things like turning on and off, detecting the sequences and being able to turn them on and off. People were hacking together all sorts of little text editors to do this. And so it seemed like there were a bunch of different tools. This was just one written by a software engineer who knew what he was doing, and it's getting some use as a result.
So from the perspective of the scientist who experiment, very often, I mean, in this case, you need to have the tool that when they write the lab notes.
Yeah.
Sometimes you have to, they have to be, very quick because whatever they see can come out quickly.
Yeah.
And the pace are probably the natural thing to do.
Yeah.
Now, are you saying that?
They said that to us.
Yeah. Then for this tool, typically, if you all these computer-related machines may not just be assigned. So are you saying that in this case you could simply have to do some processing so whatever node can go into the system that people can share?
Yeah.
And is there any way to do online? Just instantaneous that can facilitate
Right.
the node writing so that they may be able to do some quick analysis.
Yeah. Yeah.
Before they write things down.
Yeah. Right now, our model has effectively been to see what can we capture automatically, so that at least the fact that this was done and when it was done can be captured and shared if they want to. But we haven't seen scientists want to share anything right away. The thing that we've seen is that they want some kind of capture, and maybe I'm just working with a bunch of idiosyncratic scientists that don't match up anything else, but none of them want to share anything right away. They want to reflect. What they don't want to do is have to make a note about what they're doing while they're doing it. The phrase that we kept hearing is that it gets in the way. It gets in the way. Because they do post hoc analysis. They say, oh, I'll try this sequence, and I'll try this sequence, and I'll throw that out, and I'll throw that out. And it's like, I think I did this 6 months ago. Why did I throw this out? Or I'm looking at this sequence, and why is this part missing? Because I've just compared it to the most recent version. In fact, the thing that we heard most frequently was, it's easier for me to rerun the experiment than it is for me to go find the files. So, yeah.
Post-processing.
Yes. Yes.
And in fact, many of them do rerun their experiments before they publish because they can't capture all the stuff beforehand and they're not really sure what they're doing.
Yeah, and so then, absolutely, that's exactly what we found, and then it's fresh for them.
Yeah.
And they validate, what's changed because the database might have been updated. But again, that's something fairly straightforward to automate. If it's captured and you've got the inputs, you can just say, go run it again and show me if there are differences. So this is what I mean about just really that we're finding that the requirements are simpler than we anticipated. It's the coordination that seems to be adding some value.
So some other aspect of scientific experiment is that very often the observation and the writing, they interfere with each other, right? I think about to write down, actually. Somehow I might miss some things I might observe. So is there any way of audio visual kind of recording?
That's certainly one of the
experiments so that things people can be post-analyzed.
That's certainly one of the things being talked about in both the Smart Lab back with the synthetic chemists and also a question mark about what kind of recording do people want. For instance, when we're working with somebody with their Excel files, they wanted effectively the macro to let them replay it, but that wouldn't replay everything, so that all the little movements of the cursor weren't captured, but just sort of the main events. So we've got a hacker right now who's trying to go through replays of what I did with my analysis. It's there in Excel, it's just there needs to be a little bit less of it. So this is what I mean about being able to pull together these tools and simply make it easy for them to turn on the macro that does this.
video, audio, and there's so much information somehow.
Well, in the case with Excel, fortunately, we're not working with audio and video. It's just replaying the data.
It seems in the case of Excel, you've got a lot of other problems. Is abstracting what was important about this particular event. I mean, sometimes a sort order might be relevant, and other times it was just a convenient way of getting it 2 items at the top.
Yeah.
And
you know, what we found in just trying to simulate this is that if we could do everything quickly, if they could, you know, press a fast forward for part of it, or have a scrub bar for the macros to replay through, they were happy. It was not having that was the real frustration. It's just, I don't care if everything's there that's not important, as long as I can somehow move through it quickly. And because that isn't there, it's like, this is what I mean about having to try and see if we can do some hacky stuff with the macro capture to let us speed up the playback. I mean, that might not be a complete solution, but just from testing it a couple times with people, it's like, give me a scrub bar. Why can't I use a scrubber on this? Sorry. You know, so it's a lot of capacity is there. It's just the toolage on it for people to use is useless right now for this kind of thing. So Excel could be a great bioinformatician tool with that. That's not even versioning, really. It's just, well, I guess it is kind of, but anyway. Thank you very much.